Hi guys, and welcome to another video in the series. Previously in the last video, we're talking about subtraction and division, right? Now you guys might think, oh yeah, that's some easy stuff. That's still elementary. Well, congrats, you graduated. We're gonna try to tackle a high school problem, not quite university. So, before we were talking about these 10 to 1 machines, right? We're gonna expressing a number in terms of base 10. Well, what if I didn't tell you what base we're in? What if it's some unknown base? It might be base 3, might be base 2, might be base 10, might be base 270, right? Doesn't matter. What we do for a machine there? Well, in algebra, normally we use this symbol. We use an x to describe any unknown number that we have, right? And so, what would happen for this machine? Well, we obviously know that's going to be 1, right? Because it's always for every single machine, that's just 1. Well, to get these dots to explode over here, that means it has to be a group of 10 dots in a 10-1 machine. So for an x1 machine, that means that it has to be a group of x dots. So we can write that as x. Well, for a 10-1 machine, this would be 100, right? Because that's 10 sets of the dots that are worth 10. Well, since these dots over here will be worth x, denoted by here, then if you have x sets of x number of points that have the value of x, then that would have to be x times x, which is x squared. This is going to continue on. We have 1,000 here. Well, that's just going to be x cubed, right? And so now we transitioned simple arithmetic, simple elementary school math into algebra. We've come up with a clear visual way to express algebra. So let's take a number from function such as 2x squared plus 7x plus 6 divided by x plus 2. Alright, I did mess up the writing there. So, this is a high school process called polynomial division, right? Because we're dividing two different polynomials. So let's deal with it with the x1 machine, right? So let's just first write this equation here, right? So we're going to have 2 dots in the x squared column. We're going to have 7 dots in the x column and 6 dots in the ones column. This is how we demonstrate this function right here. Now remember in the last video how we were dealing with division. We took the signature of this one. So the x plus 2 signature, well, that would be 1 dot next to 2 dots, right? It's like if we had in base 10, we'd have 10 plus 2, which is 12. That's the symbol for 12. Well, now for polynomial division, we're just looking for these groups of x plus 2, because that's what division is, looking for groups of some number. Well, we can see that's one right here, so we can add a tally mark there. We see another one right there. We can see another one right here. See another one right here. And see another one right here. So that's 2 tallies there and 3 tallies there, right? Well, now instead of just writing 23 like we had for base 10, this is base x. So it's going to be 2 of these x's, so 2x, plus 3 of these 1s, so plus 3. So we get this result right here. Remember back in the video, we dealt with 276 divided by 12. Well, this is the same thing. It's just in base x. So this is quite a simple problem, but we can deal with what's called a lot higher order polynomials with this, because it's just the same method. It's just going to be longer. So let's deal with a little bit harder of a polynomial. Let's deal with x to the power of 4 plus 2x to the power of 3 plus 4x squared plus 6x plus 3 divided by x squared plus 3, right? Now you're like, whoa, that's a big polynomial, looks quite hard. Well, in mathematics, you have to look and describe the problem in the way you want to solve it. So let's describe this polynomial right here in the x1 machine, right? Let's take an x1 machine. It'll have to have 5 boxes because it's a 4th order polynomial. So it's an x1 machine, as you can see. This 1, x squared, x cubed, and x to the power of 4. So we have 1 dot here, You have 2 dots here. We're going to have 4 dots here. We're going to have 6 dots here. And 3 dots here. Alright? Now we look at the signature up here. Well, x squared plus 3. We know that would have a dot signature of 1, no dots, 3 dots. Well, we need to look for them here. Well, we can see we have 1 here, right? We see we have 1 here. You can see we have 1 here. Oh, and we have 1 here. So we just add up the groups. We have 1 here, so that's going to be 1 there. We have 2 of them ending here, so that's 2. Then we have 1 of them ending here. So you just express it again. That's going to be x squared plus 2x plus 1 is the result of this polynomial division. Looks pretty cool. But some of the more keen-eyed viewers will look that we're avoiding something. We're avoiding negative numbers. So let's try to deal with a problem with it right now. See what happens when we try to use the antidots. Alright, so let's take x squared minus 3x plus 2 divided by x plus 2. Alright, let's try to solve that. So let's first express x squared minus 3x plus 3 in terms of base x, right, in the machine. So we're going to have x squared here, we're going to have x, and we're going to have 1, right? We have 1 dot here. Well, we just make sure we know that's the x1 machine. Then we have, let's make it x cubed. I like that better. There we go, x cubed. We have a dot there. All right, so we have dot here. We're gonna have no dots here. We're gonna have 3 antidots here, and we're gonna have 2 dots here. All right, and then the signature we're looking for is 1 dot next to 2 dots. Well, remember back in regular division with numbers of base 10, right? We simply unexploited these dots over here, right? So we had a certain amount of dots here. Well, in base 10, we could have it so that we have 10 dots back here. Now we're going to have x dots over here. We don't know what x is, so we can't use the strategy. So instead, we have to look at this right here. What is actually in this box with nothing in it? Well, there's a whole bunch of possibilities it could be. I mean, this is 0x squared. But so is this. And so is this. Now look what we've done. We have 1 dot, right, next to 2 dots. Well, that's a group that we can use. That dot is in there. We have 1 there. Well, we can do that here as well, right? So we're gonna have 1 dot next to 2 dots. That's just 1 group. Now we're kind of stuck. We do have 2 antidots next to 4 antidots. But remember what an antidot is when we had division. When we're having division, we're simply saying, let's say 13 minus 2 is the equivalent of 13 plus negative 2. So these are just negative amounts of these values. Well, then we can use this as a group. We have 1 antidot next to 2 antidots. That'll be a negative 1. We could do the same thing here. That's going to be another negative 1. So if I actually look at the different columns, then that will have to be an x squared. That's going to be negative 2x. And that's going to be x. Or 1. Not x. Definitely not x. We're in the 1's column. Right? So the result of this polynomial division is x squared minus 2x plus 1. So we can actually use negative numbers. It's just we have to have this loop around of using the implicit definition of the empty space. So let's deal with polynomial division that is quite useful in a certain sector of math. So let's take the polynomial division of x to the power of 5 minus 1 divided by x minus 1. Alright? So first, let's describe x to the power of 5 in an x to 1 machine. Alright, so we're going to have 6 boxes because we have a 5th order polynomial. So we have 1 dot there and 1 antidot all the way over here. And what we're trying to divide by is x minus 1, which has a signature of a dot next to an antidot. Now we can use the same thing we did before, where we simply implicitly look at one of the boxes and then adjust it to fit our needs. So we see here, we can add an antidot and a dot, and so we get this signature here. That's a group there, so we have one there. Well, we can continue that down right here. That works. We just keep on doing it. What we want, we're making it and then dealing with the consequences. We have another one here. Boom. And well, we're left with that, which is another group. So we can say that is equal to x to the power 4 plus x to the power 3 plus x to the power 2 plus x plus 1. And so this is basically this function, or this polynomial division, is used a lot in number theory. Basically, when you're trying to see if some number will have the divisor will result in no remainder. Let's say we're trying to check if 23 can be divisible by 24, or by 22, right? Or not 23. Let's write x in terms of 23. Sorry. You have 23 to the power of 5 minus 1 over 22. We need to see if this number is divisible by 22. Well, since we can see here that it works out with no remainder, that means that these two numbers are divisible, which is extremely important in number theory. That's enough for the video for today. See you guys later.